Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj explaining physics of animation. It is part of VTU engineering physics syllabus for computer science and allied branches. In my previous videos I already explained some of the fundamentals connected to the physics of animation. Okay, now let us proceed further. So in this video I would like to explain concept of uniform motion and then linear motion, and then how to do the timing in case of linear motion and uniform motion. First of all, what is linear motion? Linear motion is also known as rectilinear motion. That means the motion of a body in a straight line. It can be horizontal straight motion or vertical motion. If as long as the path is path is only along one axis, either along x-axis or y-axis or z-axis, we call it as linear motion. For example, a marble rolling on the floor. Okay, so it goes like this. This is uniform. This is the linear motion. Or when you drop a stone, it falls under gravity. That is also linear motion. Okay, so linear motion is motion in one dimension. That's all. It is motion in one dimension. Now, during the motion, if the body is not accelerated, then it is called uniform motion. If the body is accelerated, then it is called non-uniform motion. I repeat, when the linear motion can be called as uniform and when it is called non-uniform. See, if the body is not accelerated, that doesn't mean that the body is not moving. Body is moving with constant velocity. You all know, according to our fundamental definitions, the rate of change of velocity is acceleration. If the acceleration is zero, means velocity is constant. So if the body is moving with constant velocity or zero acceleration, then it is called uniform motion. If the body is moving with constant acceleration, then it is called non-uniform motion. That means body is now acted upon by external force. See, here comes Newton's first law and second law. If the body is moving without any acceleration, it means to say that no external force is acting on the body. So try to recall Newton's first law. A body continues to be in the state of motion unless it is acted upon by external force. That means in order to stop the body, you have to apply the force, or in order to accelerate the body, you have to apply the force. Otherwise, in order to keep the body in the same state, either state of rest or state of motion, you need not have to apply the force. This is the essence of Newton's first law. Okay, so recall Newton's first law. What actually it says? A body continues to be in the state of uniform motion or in the state of rest unless it is acted upon by external force. So in case of uniform motion, I am not applying any force. That is first law. Suppose if I want to have acceleration, now it is non-uniform, then what I have to do? Yes, according to Newton's second law, I must apply the force, and force applied causes the acceleration, and you know this famous equation, force is equal to mass into acceleration. I hope you got the difference between uniform motion and non-uniform motion, and both of them belonging to linear motion. That means I am talking only about one dimensional motion. That's all. Okay, now I consider both uniform and non-uniform motion and how to do the timing for uniform and non-uniform. In my previous video I already mentioned what is timing. Timing is nothing but the total time taken by that action to complete from starting point to ending point, or how many frames to be accommodated for the explanation of complete action. For example, this marble is going from A to B. To go from A to B is an action. Movement is an action. In order to display this, or in order to depict this in animated the movie, how many frames I have to design? That is nothing but timing. Okay, so now how to do timing in case of linear motion, and that too in case of uniform motion, non-uniform motion. Okay, uniform motion means acceleration is zero. Non-uniform motion is acceleration is not zero, but it is constant. In uniform motion, no force is applied. In non-uniform motion, force is applied. Now I will come to this force later on once again. Now let us restrict only to this one, that is uniform motion. I already told you, in uniform motion the body is moving with constant velocity. So if the velocity is constant, it is very easy to do the timing, because in each interval of time the body covers same amount of distance. Therefore I can design the frames accordingly. right? So spacing can be designed accordingly because velocity is constant, distance traveled is constant, equal distance is traveled in equal intervals of time. Yeah, recall the definition of velocity. Velocity is said to be uniform if a body covers equal distance in equal intervals of time in the same direction. See, this is physics, okay? So where is physics in animation? As I told in my first video, it is there in each and every concept. One way or other we are using physics only. That's what I am doing here. So if a body is moving with uniform velocity, then spacing is constant, timing is constant. Timing is very easy to do. So you keep the equal spacing. Suppose if the body is moving with lesser velocity means lesser space, then in that case you have to keep the frames very close to each other, and again the spacing is same only. In each case it is a constant spacing. Suppose if the velocity is more, spacing is more, again the spacing is equal only. Whatever the spacing you provide here, same spacing you have to provide even here also, even here also. So this is about the timing for uniform motion. I just repeat, in uniform motion the body is moving with constant velocity, therefore timing is very easy. Equal timing we have to provide between the successive frames, equal spacing we have to provide between successive frames. That's all about timing for uniform motion. Now coming to non-uniform motion, where I am applying the force on the body. Well, where you come across with the force acting on a body, give example for non-uniform motion. Give example for a body moving with constant acceleration. Yes, constant acceleration, several examples we can give. When the body experiences constant acceleration, when the force applied is constant. The best example is a ball or a stone falling under gravity. Gravitational force is constant, acceleration remains constant, that is 9.8, that is equal to g. So gravitational force is a constant force, and the body falling under gravity is the best example for uniform motion. Okay, another example, you are driving your car on a particular road, friction between the car and the tire and the road exists. That friction is constant. As long as the road condition is constant, friction is constant, so frictional force is constant force, and thereby whatever the acceleration the body or car or anything experiences, that is also constant. So we can use several examples for constant force and uniform motion. For example, a charge moving in uniform electric field, that is also a best example for uniform motion, because force experienced by a charge in the uniform electric field is EQ, where E is electric intensity, Q is charge on the body. Suppose if a charge is moving in uniform magnetic field, force experienced by it is BQE sin theta. All these things are known to you. As long as magnetic field is uniform, force is also uniform. So all such motions are considered as a body moving with constant acceleration. Got it? Now actually, constant acceleration, uniform force is logically correct, but when it comes to our movements, in these examples, no doubt, when I drop the stone, definitely it will move with constant acceleration. But when I am walking, I may not be applying uniform force for walking, or when I am pushing the stone, I may not be applying the same amount of force always, correct? No. Or when I am hitting the ball, I may not be applying the same amount of force for each and every hit. So that way, in day-to-day life mechanics, force applied is not constant, force applied is variable, okay, and therefore acceleration is not constant, acceleration is also variable. But now we shall restrict ourselves to constant acceleration, and how to convert our these day-to-day movements into normal cases, or how to convert that into a case of constant acceleration, that I will tell you now. Of constant acceleration, we use one rule called odd rule for timing. Timing is done with the help of odd rule in a body moving with constant acceleration. What actually this odd rule says? Now comes the definition. According to, see, any motion for that matter, either it is accelerated or retarded or decelerated. In my previous video I said, when a body starts moving, it is acceleration. When body stops moving, it is retardation. Like that we treat it in animation. Okay. Now for smooth smooth animation, we have to adopt what is called slow out and slow in. That also I mentioned in the previous video. Now coming back to odd rule. What odd rule says? According to this rule, distance between two successive frames. You see here I am talking in terms of frame. Each image is frame. You know the definition of frame. What is frame? Each photograph is frame. Each picture is frame. Each drawing is frame. Okay. So distance between successive frames during the motion of a body is calculated or is obtained by multiplying the base distance. What is this base distance? I tell you, by multiplying the base distance by odd numbers like 1, 3, 5, 7, etc. for accelerated motion and multiply the base distance by 7, 5, 3, 1 for decelerated motion. I repeat, this is the statement of odd rule. I repeat once again. According to this rule, distance between the successive frames is calculated or is obtained by multiplying base distance by odd numbers like 1, 3, 5, 7, etc. during accelerated motion and multiplying the base distance by 7, 5, 3, 1, etc. during decelerated motion. This is called odd rule. Now I will explain what actually this odd rule stands for. Before that, let me explain base distance. What is this base distance? Remember, during animation we have to make several frames. Ease out, ease in, or slow out and slow in. Recall the previous video. When a ball is entering the scenario, we draw many frames initially. Later on the spacing keeps increasing. Or you recall the pendulum. Initially spacing is less. Later on spacing increases. This is the spacing. Okay. Now each spacing is a distance actually. Among each spacing, find out which one is the smallest distance. That is called base distance. So what is base distance? It is the smallest distance between any two frames. Base distance is the smallest distance between any two frames. And we can show that base distance, I write it as B distance, just to say this space, is equal to total distance traveled by the body during the motion divided by last frame minus 1 whole square. I will explain this later on. Last frame minus 1 whole square. Suppose during this flow, this marble covers a distance of 4 meter. Let us say there are totally 9 frames. Then this becomes 4 divided by 9 minus 1 whole square, that is 4 divided by 8 square, that is 4 divided by 64. So divide this 4 by 64. 4 ones are 4, 4 6 1 by 16. 1 by 16. Okay, it is 0.012, something like that. That is the smallest distance, that is called base distance. So in timing, first check how many frames to be designed. Among them, already, you see, while framing you must have this type of framing only, not uniform spacing. Uniform spacing is allowed only for uniform motion. Remember, we are not talking about uniform motion, we are talking about motion which involves acceleration, so in which body is accelerated. Okay, for accelerated motion the odd rule is applicable. According to odd rule, when you multiply base distance by 1, 3, 5, 7, etc., you will get the distance between two successive frames. It can be from 1 to 2, 1 to 3, 2 to 3, 3 to 4, 4 to 5, 4 to 7. Any frame you can find a distance. And base distance is the smallest distance between two successive frames. And how to find that smallest distance? With the help of this formula, that is total distance by last frame minus 1 whole square. And dear students, remember, remember, this base distance is going to be the distance between first two frames for slow out process. I already told you what is the slow out, the process in which the body getting accelerated. So distance between first two frames is the base distance for slow out. Distance between the last two frames, see why last two frames, okay, as you continue this process, now the last two frames will be like this, and that distance is the base distance for slow in. So what is the base distance? It is the distance between two successive frames, and that is the least distance. How do you find out? In case of slow out, it is the distance between first two frames. For slow in, it is the distance between last two frames. Keep it in mind. Okay, now coming back to this, I will explain the odd rule. Odd rule says, in order to obtain the distance between any two frames, the distance must be, base distance must be multiplied by odd number. Let me explain by taking one example. Best example is a stone falling under gravity. I have a stone over here. This is a starting point. As it falls down, so it will come to this. See, whenever I draw an image, you please treat it as a frame. Treat it as a frame. Like this, like this, like this, like this. Okay. So totally I have 1, 2, 3, 4, 5, 6. 6 images means 6 frames I have. 6 frames starting from this position to this position. Okay. Now look at this, the spacing is increasing. So this is the base distance. This is the base distance. I consider this distance as, say, S1, that is from frame 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So these are the 6 frames. Now initially its velocity 0. Okay, are you following, dear students? Yes, I hope you are following. Initially velocity 0. Well, after 1t, that means after t second, distance traveled is, that is after, let us say 1 second only, distance traveled is S1 is equal to half gt square, that is S is equal to ut plus half at square formula. Anyway, u is 0, I am writing it as half gt square. So t is 1, therefore S1 is equal to half g. Got it? So that is the distance traveled in 1 second. Like that, after 2 seconds, write this, definitely this will be 4 times half g. You know how 4 times half g? Because I should write t square, 2 square, 2 square is 4. Next, after 3 seconds, S3 will be, come on, tell me how much it will be? Sir, it is 9 times half g. Yes, after 4 seconds, what is the distance traveled? It is 16 times half g. Correct? Now look at the similarity or the relation or the connection between S1, S2, S3, S4, S5. Okay, let me write S5 also. After 5 seconds, S5 is equal to 25 times half g. Okay, now just 1 minute. Okay, I call this as frame 1, F1, F2, F3, F4, F5 and F6. Now I want to know the distance, two distances, that is distance between two successive frames, that is F1 and F2 or F2 and F3, F3 and F4. Definitely this spacing is not same because it is not a uniform motion. It is not a body moving with constant velocity. It is a body moving with constant acceleration. Definitely the spacing keeps on changing. So I want the spacing between 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6. Also I want to know distance between 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. That is total distance traveled. So I construct a table here. Follow carefully this table. First column represents frame number A. I call it as A. Second column represents distance between any two frames. So A is equal to frame number. Just there is no enough space, I am writing here. B is equal to distance between successive frames. Okay, successive frames. And then C. C is the distance between first one and any other frame, any other present frame. It may be from 1 to 2 or maybe 1 to 3, maybe 1 to 4, 1 to 5, 1 to 6 like that. Okay. Now, so this is the table. First I take the first frame, frame number 1. When the body is in the frame number 1, that is in the position 1, no distance traveled, therefore B is 0, C is 0. Okay, you can write it as 0. Next, take the frame number 2. From 2 to 1, what is the gap? It is 1. It is 1. How do you say, sir, it is nothing but 1. It is here, no? This is half G. Half G is 1 times half G minus 0, that is equal to 1 times half G. I take this half G as some number. Let us say this is nothing but 9.8 or 10. So 10 by 2 is nothing but 5. So 1 into 5. This whole thing I take it as say x. Therefore it is 1 into x. Like that it is 1 into x. Then the distance traveled is it is nothing but previous distance, that is 0, and this distance 1, that is equal to 1 meter. Okay, so from 1 to 2, that is from frame 1 to 2, distance traveled is 1 meter. Now I will take frame number 3. For frame number 3, what is the distance between 2 and 3? You have to calculate between 2 and 3. 2 is 4 times, 3 is 4 times, 2 is half times. Not half time, 1 time. So 4 minus 1, it is 3. So for third frame, actually it is actually this should come here. There is a small shift in the process. So S2 is for F3, frame number 3. So it is 3, and total distance will be 0 plus 1 plus 3. 0, 0 plus 1 plus 3, that is equal to 4. Okay. Now coming to frame number 4. Frame number 4, it is S3. Okay, so let me write it like this, like this, like this. Okay, so initially there is no frame at all. Okay, well, for a fourth frame, S3 is 9. 9 minus 4 is 5. So remember, B stands for distance between successive frames. I am writing the distance between S2 and S3. That means these two frames. Earlier I wrote this, earlier I wrote this. Now I am writing this. Next I am going to write this. See, this distance is 1 times, this distance is 2 or 3 times, this distance is coming out to be 5 times. That is why it is called odd multiple. Okay, so if you treat this as the base distance, when I multiply 1 by 1, I get this distance, 1 by 3 I get this distance, 1 by 5 I get this distance, and so on. Okay, so 5. Okay, now from 1 to 4, what is the distance? 1 to 4, it is 0 plus 1 plus 3 plus 5, that is nothing but 9, right? So I am here. So from the first position, distance traveled is 9. From the first position, distance traveled is 4. From the first position, distance traveled is this is 9, this is 9, this is 9, and this is 4, and this is 1. Okay, so this distance is next. I go for this distance, that is frame number 5. For frame number 5, I must have what? I must have this minus this difference. 16 minus 9, that is nothing but 7, and total distance will be 0 plus 1 plus 3 plus 5 plus 7, it is equal to 16. So this distance is 16, right? And now coming to the last frame, 6th frame, by the time the ball comes to this position, it is already covered 25 times half G. Now the distance between these two frames is 25 minus 16, that is 9. That is 9, and that is nothing but total distance 0 plus 1 plus 3 plus 5 plus 7 plus 9, that is equal to 25. Now look at the last numbers. This can be written as 1 square, this can be written as 2 square, this can be written as 3 square, this is 4 square, this is 5 square. Suppose if I have one more frame, it will be 6 square, and so on. So this is odd rule explanation. I repeat, look at the multiples 1, 3, 5, 7. These 1, 3, 5, 7s are odd numbers, and using this odd number I am multiplying the base distance. Base distance is half g here. Okay, when you multiply the base distance by 1, 3, 5, 7, etc., you get the distance between two successive frames. Okay, and not only that, you can calculate the total distance traveled. So this is the odd rule for slow out process. Here slow out means the body started slowly and then started accelerated, and finally it is hitting the ground. Suppose if it is a retardation, of course it is applicable not only for vertical motion, even for horizontal motion also. So if you are speeding up, same rule you apply, slow out. For slow in, what to do? Say for example, one speedy car, okay, is moving and the driver applies the brake. So after applying the brake, it travels this much distance, then this much distance, and then this much distance, and then this much distance. Let us call this as the base distance. Let us say 1. Then you multiply 1 by 3 or 1 by 5 or 1 by 7. So base distance you have to multiply by 7, 5, 3, 3, 1 in order to get the spacing. And using that spacing you can make the timing. So this is odd rule. So odd rule says, I just explained odd rule. Odd rule says, there is one more concept called odd rule multiplier that I will take up in the next video. Odd rule says, according to odd rule, if the base distance is multiplied by odd numbers like 1, 3, 5, 7, we get the distance between successive frames, and this is for accelerated motion. For retarded motion, if you multiply the same base distance by 7, 5, 3, 1, you get the spacing between successive frames. Okay, so this is odd rule, and that odd rule can be explained with the help of equations of motion. Well, I will stop here. In my next video, I will come back with what is called force, which is greater than 0, and acceleration is not constant, variable. If it is variable, how to apply the odd rule, and also what is this odd rule multiplier, that I will explain in the next video. So just focus on this table, practice this table. You can expect numericals on this particular concept. Well, I will stop here. Thank you very much.